Hey guys, how's it going? I hope everyone's doing alright. Voxel Rifts, CGO Clan, Essie Woods, Eustace, good to see you. And Eddie Dev, how's it going, guys? So, let me know if the music is too loud. I can turn it down a little bit if it is. But today we're going to be working on Ambient Occlusion again because it's not completely good. And what's up, Sam? Good to see you. Because there are still a couple of problems with it. And so I'll see if I can fix those up today. And I'm also going to fix a couple other things too. Yep. Rust in Windows is a pain. Well, that's good to know, I guess. So this is what we got right now, which is probably a good thing to see. Basically, you can see that we do have some problems like this block to this block. You'll notice that it's kind of too bright. And if I exaggerate the effect, you'll see a little bit clearer. So if we just turn up the ambient occlusion to like 20, then it should exaggerate that. Okay, and it does. So what's happening here and why does it not look right? Well, the reason it doesn't look right is because from this vertex's point of view, it's in like this state 0, like the vertex down here, if I'm looking down. So it's in the state 0. So basically what's happening is it sees this block right here and it thinks that it has to be dark, which it does for this face. But if we're looking from this face's point of view, there is no block next to it that should make it. Yeah, that should make it so that it has to be. I think this is what's happening. I'm not completely sure because that's what makes sense to me. If we go ahead and reload the shaders again, and this is another problem we're going to have to fix too, because this is really annoying. So if I do this and then we do this, then that should, oh, and I'm also going to do this, comment this stuff out again. Show us the different ambient occlusion levels by color, which is just helpful so we can sort of debug this a little bit better. Yeah. Okay, and what are we getting here? I think it's just mad because what am I missing? Let's see. So it says the operation is invalid when the uniform is a matrix. What is this complaining about? Weird. Okay, so that's not happy about something. But yeah. And Damao, how's it going? And Hilbert Curve, good to see you. And Voxrifts, you've been trying out Odin for a personal project and it's really good. Recommend to anyone who's doing language design. Check it out. Cool. So yeah, this is basically just a debug view. And so like colors the different states by like red, green, blue, or I think yellow. Or no, black is the last one, yeah. And so basically the red is like state 0, I think. Green is different state. And this is a problem. We shouldn't be getting a green state up here. It should be red because it doesn't have any blocks, which we are getting appropriately here, right? Like this is all red, which makes sense because there's no blocks around it. But this one isn't. And if we look, what I'm basing this off of is this article here. And so these are the different states, right? And so those red ones are this 3 state. Where basically you don't have any blocks around this corner vertex, and that's what we should be getting. And my mouse cursor is not being highlighted, so let's fix that real quick. Looks like I gotta restart the whole thing here. So there we go. So yeah, this is what we're gonna be working on basically. Reloading shaders does not work in your game right now in your game. I tried it too. It does work. It's just if you make a mistake, it crashes. So if I leave out a comma, and this is one of the things I was going to talk about fixing because it's annoying, then it'll crash. So yeah, that's the only problem. We'll fix that though, because that is kind of annoying, and that was going to be the first thing that I did. So let's go here. And it's fine now. Yep. So that's all fine. So let's go and fix that up real quick. It should be pretty easy to just change that up. So if I go into shader.h, I'm just going to add a function. I originally didn't have it so that you could just reload shaders within the shader itself because I always figured, I don't even know what I figured. I just figured that if it wasn't correct, you would never want to continue with it. But that's not true at all, because sometimes you do want to just keep the old shader in memory until it works right. So let's add a method here. Void reload, or I guess like hot reload. Doesn't really matter, it's the same thing. Is this const? This is not const. Okay, so we'll do this, and then if we go to shader.cpp, we can go ahead and fix this up. So basically what we're going to do is we're going to change the compile method, which right now will crash if we fail because it has an assertion in here somewhere. Yeah, right here. So basically just asserts linking failed and then crashes the program. And so we can fix that up pretty easily. And so we'll just add this method right here. And we'll basically say, try to compile the new one, and then if it fails, then we will basically just have this return a boolean instead, so that we can hold on to the old one. So we'll change this to return a bool. This will return a bool. And we'll go through here. Okay, so if we fail here, no need to do this. We might still want to print this, just like glog or error, just not crash. So we'll do that. And then we can return false here. And let's see, then we'll go down, and this should delete the shaders too and everything. Yep, so it deletes the shaders. So we don't have to worry about that. Does it delete all the shaders though? Uh-oh, I think this is a bug. I mean, technically it's not a bug because I was crashing before, so it doesn't really matter if it didn't delete everything. But we create a program, and then we loop through, because I copied this from Cherno, all of our shader sources. And then we compile, and then we say if compiled is false, we only delete this shader. We don't delete the program or the other shader. Well, that's dumb. We should delete everything. So let's go ahead and we'll delete the program too. And the other shader, we'll say delete program, and this will be our program. Whoops. And then we also say for int, I guess, since we're doing this loop, I really don't like this. I want to change this, but it doesn't matter too much. And why are we doing it this way? For auto key value and shader sources, this just isn't the best way to do this stuff. Let's, instead of doing that, how do I store the shaders? Let's see. I just attach it. Okay, here we go. GL shader ID, shader index plus plus. Okay, cool. So we can just go ahead and, where is this stored? GL shader IDs. Okay, that's just an array of 2. Okay, so we'll just say GL delete shader, GL shader IDs 0, and I'll put it to do. Don't have this in a dumb loop. Okay, because it just doesn't make sense. So we'll do that, and we'll do 1, and we will do a check too. We'll just say if this is valid, we'll do that, and then we can just say that, and we'll do the same thing here. So we'll say if that's not invalid, then delete it and set it to invalid. I mean, honestly, this doesn't matter too much because it's just gonna break out of there afterwards anyways, but we have it there. So yeah. Okay. There we go. Cool, so that's good. Let's just initialize those two so that we actually know they're invalid. So let's just go ahead and say that's this. Did not mean to do that. Okay, there we go, cool. So we got that. Now we'll actually delete stuff appropriately, which would have been bad if we didn't. And we can get rid of this now too. So if we fail, we just delete both shaders and then we just set them to that. That's all good. Langors, how's it going? I'm not receiving notifications that you're live. Huh. Let's see what's, maybe take the hint. Oof. Not getting notifications. That's weird. I did post something in the Discord at least to stream notifications. So I think I did, right? Yeah. I said, hey guys, I'm live on Twitch, and I pinged stream notifications. Maybe I should ping the mod rules too, so that you guys at least get them, because that might be helpful. But yeah, so we're gonna do that. We delete the shaders. We have a to-do here. I haven't looked at to-dos in a long time, so I should probably actually look at those pretty soon and fix that. But yeah, so we got that. Then we link the program if it's successful, if the linking fails. Okay, yeah, and then see, this is where I do appropriately delete everything here at least, and I don't like this. That's better. Okay, so we'll do an error there, and we'll say error here, and then we'll return false. Okay, cool. So that's all good, and then we basically go and run our reflection here, which that's basically going to go ahead and cache all of our uniforms, their locations. Let's fix this too. And then we go ahead and we detach the shaders, and we should destroy the shaders. Do I destroy them here? No, I do not. Okay, so this is another bad thing. We should also destroy these shaders, gl delete shader. And then we'll pass it the ID. Yeah, so that's not good. I don't know why I did not have that. Do I have this somewhere else in here? No, I do not. Okay, so those were some memory leaks. That's just not good. This isn't good either, because we already deleted that. I thought I got rid of that. Oh, that should have been gl delete program. Okay, cool. So that's all good now. All those memory leaks are cleaned up, and we shouldn't have any problems there. And then we cache all those uniforms. Cool. So now what do we need to do? It was good to go through that too, because I kind of needed to see what we did there, so we know what we have to undo when we hot reload a shader. So what we can do when we hot reload a shader is, first of all, we need to clear all the cached uniform variables from the shader. But we'll only do that if it's successful. Because, yeah. Actually, I don't even know if we have to worry about that. If it's successful, what are we going to do here? We're basically going to put this into our hash map. We put in the uniform name, the location, the program, which should just overwrite the old one. And if that's the case, I'm just kind of fine with that, because if we overwrite the old cached uniform, that's fine. It's successful anyway, so we don't have to worry about it. So we're just not going to worry about the caching. It should just sort of work. But what we do have to worry about is if it fails. So what we'll do is we'll say old shader program equals program ID. So we'll kind of grab that, and then we'll go ahead and we'll say free. Well, no, we won't say free yet. We don't want to free the shader. We'll just say compile. And we'll give it our shader path. What did I call it? Just path? File path. Okay, we'll give it that. Let me check one more thing too, because I think that might allocate memory. Yes, it does. Okay, let's just add a flag there, because I don't feel like doing anything fancier. Save file path string equals true by default. The reason I'm not using a standard string here too is because of some stuff that happened earlier where I thought it was causing problems, but it really wasn't. So yeah, but it's fine. I really don't care. Okay, so we'll do that. We'll save it if we want to save it, which is true by default, file path. Okay, that's good. And then we can go ahead and just say, go down. Right here, we don't want to save it. Okay, so we'll say compile, don't save. So we try to compile, we can say if not, then, what's wrong? Oh, double parentheses there. If not, then we'll just do program ID equals old shader program. And we should get all the errors printed out and stuff anyway, so it's all good. Otherwise, if we succeed though, we want to free the old shader. And to free the old shader, we basically just need to delete that program. Yep, that's all we gotta do. So then we can just say if old shader program does not equal the bad handle, then we'll just say gl delete program. old shader program. Cool. So that should be all we need to do. We basically replace it if it succeeds. If it doesn't, we should just do that. Let's see if it works. So if we compile it and it breaks, it shouldn't have anything wrong with it. And Joe Mega, how's it going? Input systems, cool. I need a, but if, for example, you change a uniform name in the shader, it will still exist in the hash map, so you may clear it when you reload a shader. That's a good point. Yep, we might want to do that. I mean, honestly, you should only be like messing with shaders and stuff in development anyways, so it's like, it's not that big of a deal, and it'll get cleaned up. So I clean those up anyways whenever you change a scene. So like when you go to the main menu and stuff, those all get cleared out anyways, but it might be worth looking into. So I'll put a to-do up there in a second. Okay, so if we change the shader and we add a error there, and we go ahead and say reload shaders. Oh, well, it's not working, so it just broke. That makes sense. So it just broke because I'm not actually using that function, and then it just kept going, and it was like freaking out because now we have bad shaders everywhere. Yeah, I forgot. We have to call this reload function. So it's there. We're just not using it. Let's go. We'll do Control-Shift, reload shaders. There we go. Cool. So let's go look for all of these. Not in include though. At least I don't think. Let's see. Yep, we don't care about any of those. Okay. So we'll go here, and then this goes ahead and calls all the shader reload stuff. So if we go into here, it's fine. Here, that's also fine. Okay, what about in here? Okay, that's all good. Let's see. There we go. Here's the first one. Cool. So then here, what we'll do is instead of destroying and recompiling, I can just say reload. And that should be good. Cool. And then inside of here, same thing. So we'll just do reload. That's good. And then I can get rid of all this. Okay, and then I think I got one more in here. Yep, so we got that and this. Okay, cool. Reload, and we'll say reload. Okay, so this might be a problem too, because I think I was using this to just sort of... Wait, what was this? Destroy, 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 compile, compile, compile. Okay, so we'll do that. Yeah, this might be a problem because of the way I was doing things before. Might be. I don't know. What happens? So we just delete the old shader program if it fails. If not, we just set... Okay, yeah. I don't think this is actually a problem then. So reload, if the shader wasn't already loaded before, this should still load it, right? Because we're still going to compile it. Oh, but this is a problem though. Yeah, this is a problem because basically I'm not saving that string. Let's get rid of this. Go back into here. This is not the best way to do this type of stuff too, by the way. Like I said, I would probably just use a standard string here if I could, but there was problems earlier, which is why I'm not using it. So let's just get rid of that. And then what we're gonna do is we're just gonna say if shader file path. Yeah, if file path does not equal null pointer. No, if file path does equal null pointer. Because it is null pointer by default, so that should fix things up for us. Okay, so we'll just save it if it's null pointer, and then that'll make it not null pointer. And then when you destroy a shader, which is somewhere here, yeah, it gets set back to null pointer. Okay, so I'm happy with that. Cool, so if we do this, we should be good. Beer Chug, thanks for following, good to see you. Box Riffs, SE Woods. There's a good amount of scamming going on with Kickstarter campaigns for games. You plan a Kickstarter for your game, Gabe? No, I am not. We got some weird stuff there. I'm guessing... Let's do this again. Yeah, definitely not doing that. Good to see you, Beer Chug. see. Eddie Dev, is the Robinhood algorithm fast? Are you talking about like Robinhood, the library I'm using, or like Robinhood? I think it's called like Robinhood ordering or something. I forget. I don't know. But it's basically like an OS round robin. Round robin is what I'm thinking. Yeah, that's something completely different. But yeah, what's happening here? So we basically say if file path. Okay, so file path is null pointer, and then we're getting what's shader file path and shader file path. Why is shader file path null pointer? Reload. Ah, because we're passing in null pointer there. That's not good. So yeah, we got a problem here, and this is coming from here. Okay, yeah. So this is what I was talking about. We never really initialize these. So let's actually do this right, because yeah. That's probably the best way to do this. So what was it like in here before? Because now I got to remember so I can copy that. Okay, let's copy this. Do that. This should be that. That's better. Cool. So we're going to have to go through, find all those things where I did a shader reload and fix that, because it's all going to be broken now. Okay, so if we go into here, nope, not in there. Not in there, right here. Okay, that's fine. That's the one I just fixed. There should be a couple more. Let's get rid of that. Right here. Okay, yeah, so let's fix this too. Okay, so let's just copy all of these. Those are all good, and then I have to go up to where we initialize things. And okay, cool. So this is still good. What about here? That's fine. That's where we do stuff. What about here? Okay, I think this is also going to be broken, so let's copy that. Go up here. Yep, that's good. Cool, and then I think that's it. Okay, and then let's also add something that's helpful for us so we don't run into that problem. So if file path equals null pointer, we'll just say glogger assert false, tried to reload a shader that was never loaded. Okay. Or we can say program ID equals uint32 max. So you can only reload shaders that have already been loaded. Okay, so that should fix that problem. We were just, having a problem because we're trying to reload stuff that's never been loaded. I think we'll still get a problem though, because I left that bug in, maybe. Let's see. Okay, the unordered map. Yes. Sorry, Eddie Dev. So yeah, that is fast. It's, I think it might actually be a little bit faster than like the standard. Not quite sure on that, like runtime and everything, but basically it's slower in debug, like literally 100 times slower. I'm not exaggerating. I tested this and checked because when I was doing debugging and stuff, I was like, why are my debug, like loading stuff so slow? It was taking around, I think like 10 or 12 seconds to load in debug. And then in release, it would go down like 2 seconds. I was like, okay, this is weird. Whenever I would load a new world, and it was like running all the algorithms and stuff. And then I found out it was because of debug iterators inside of the maps and big whole thing. And so basically I just switched to Robinhood and it was better. The most essential thing for fast hash maps is still the hash. No, the problem with the standard though is they have this thing called Debug Iterators. Basically, if you just look up, do std hash, or I guess unordered map, do debug iterators, allocate memory, because what happens is they allocate new memory every single time that you create an iterator. So every time you just want to iterate through the stupid hash map, or if you just want to look something up, if you're in a debug build, it will allocate memory for that iterator. And it's super annoying because then it slows things down so bad. And the problem gets fixed in release mode, which is good, but when you're debugging stuff, you want to like actually be able to debug stuff. Let's see. Okay, let's just see. I mean, okay, debug iterator problem. because this is a huge problem, and I don't know why they do it this way, at least in MSVC. Yeah, so why does Iterator debugging slow stood unordered map 200x in debug builds? So this is what I'm talking about. It's just so stupid. And then if you look down here, they're going to say, yeah, so then they say the fix is to switch to boost unordered map. It's like, why? So he's saying collisions of the source, but that's not true. It's actually the debug iterators, and that's what he does here. So I don't get why he's saying collisions are the source if he's saying you have to turn off debug iterators here. And then does it even say? Yeah, iterator debug makes standard containers very slow in debug builds for large containers. It must be undefined around STL includes. But if you do this, it causes all their problems and stuff, and it's just really annoying. Yeah. I'm talking about general, not a specific hash map, is a specific compilation mode. Yeah, no, I agree. Like a good hash leads to a faster hash map, but the reason I'm using Robinhood is because of that specific reason. So yeah, just use a linear search at the point. Well, I wanted the advantages of a hash map because it was especially important for the case that I needed it. But yeah, I agree. SE Woods, any originals on my keyboard? Nah, I'm not creative like that. I just play stuff other people make, and that's about the extent of my creativity. Okay, so let's see if this actually works, because kind of went off. Okay, so take away a comma there. We're gonna get an error. We reload. Okay, cool. So it's all still working, and then we get an error in our debug prompt that says unexpected type identifier. Cool. So now we can make mistakes in our shaders, and it'll just keep the old one loaded until we actually successful compile, which let's just make sure this actually works. If I comment this out and we re-comment this stuff out, we should just get red clay-like cubes. So if I do that, then it works. Cool. So it does successfully reload them and everything, and we are all good there. We still have this problem though, which we have to fix. And so I added this mode, which is basically we're just forcing everything to be this reddish color, because I went into Blender and did some renders just to get an idea of how ambient occlusion should look. So these are some renders done in Blender just to give us an idea of like what things should look like. And I basically did the same setup that guy did some extra setups and stuff just to get like an idea of how it looks. And the reason I did this specifically is because you'll notice like it's kind of dark, but you'll notice like especially around here, the top of this cube is brighter than the side of this cube. And that's kind of what gives this the definition on the edges and stuff. And so I think that's in part due to the directional lighting or something that Blender is doing. I'm not quite sure because, but it also has to do with the way these cubes are combined. If we are thinking about it in like a few different states, it should fix that up and stuff. Yeah. And Joe Mega, I'm sad you're not going on the recompile and save changes route. Well, I don't know. I could do that later if I really wanted to, but I feel like it's just a bit overkill at this point because I already have everything in here. The reason I don't want to do that too is because there are specific shaders sometimes that you are tied to specific scenes and stuff, and it's a little bit hard to tell which shader. I don't have any sort of data structure to do all that stuff, so, and I don't feel like adding that implementation, but yeah. It looks brighter, but it isn't, I think, yeah. Well, in the one article here too, this actually is a different state too, as what he's actually defining it as, at least. Where basically if you have a vertex here, it is a different state than if you had one on all sides. So like this is darker for this vertex than it would be for this one. So it kind of is in this model, at least, to give it the same kind of effect, but it's obviously not working 100% correctly because we get this. And so that's what I'm wondering. Basically, Sam, I don't know if you're still on here because I know you had this same problem too. And I'm wondering if you are on here and if you're seeing this. Is this the problem that you were getting to, like something like this, where basically you'd have a bright block? Okay, you are. Where you would basically have the bright block and then dark block. Okay, so you were getting this same problem too. And it's weird because it only happens when you have a situation like this, right? So, yeah. SEO, it's actually never used debug mode. How noob is that? Well, I mean, if you're in Java, I don't think Java has like specific debug mode, so I wouldn't be too concerned about that. You should be fine. Try to visualize the blocks calculated from the direction. Yeah, so if I was looking at the blocks, so if we were looking at this vertex, what it's looking for is it's looking for these 3 blocks. And so since there is no blocks in those 3 corners, it's not getting anything. And this is also another problem I want to fix today. I know what this is, and I thought I had fixed it, but that might be in a different branch, so we might pull those changes over. But yeah, so it's looking for these 3 blocks, which don't exist. But yeah, so if I place that there, you'll notice that it fixes it there. And then if I place a block here, it fixes it there. And then if I place 2 blocks there, it looks good there. But yeah, which is wrong. Oh, okay. I thought that was right though, because if we're looking at that vertex, according to his diagrams at least, if we're looking at that vertex, then the state that this would be in is this state, because there is no surrounding blocks. Technically, right? Because it's directly on top. He doesn't have any state for something that's directly on top of the vertex. So like, technically that's correct. Or are you saying, wait, okay, I think I see what you're saying, Sam. So basically you're saying I should be looking at it from this perspective, like this vertex is like this corner of this block. And so I should be, but even then, or like it's this corner of this block, and so it should be seeing that. And this is this corner of this block. Show me what do you think is right on some side in vertex, and I'll say yes or no. Languors, there's debug mode for Java, but I don't think it changes the code itself. It just lets you add breakpoints and whatnot. Okay. But yeah, I think that's what you're saying, Sam, right? Like basically treat this vertex like it was this corner of this block instead of that corner of that block, and then same thing here. I think. And if that's the case, do I basically extrude from the normal? So do I basically go out this way and this way, and then use that vertex and then check the surrounding blocks around it? I'm not sure. Place 3 blocks on some side and tell me which vertex it is. So should this vertex be looking at these 3 blocks? No. Okay, so I'm still thinking about this wrong. These 3 blocks? We're just kind of gonna go back and forth here until I see what you're getting at, because I'm still not quite sure how this is supposed to work. And this is what I had a feeling was my problem the whole time too. Okay, so still no. Yeah, I am not sure. Could you send a screenshot if you are in there, like with just your own game? Sort of set up like this situation, just like a little bit of like that, and then just tell me which one with like maybe a different colored block or something. Oh wait, yes. It should be looking at these 3 blocks. No, okay. The reason I'm asking Sam on this too is because he had the same problem recently, and so he was able to resolve it, and I'm basically, you should do a Discord call or something. Do you want to do a Discord call real quick, Sam? I'm not sure how the audio would come through and everything too for you guys. Not sure if I can... Yeah, actually, I think you guys would be able to hear the audio and everything. I think you should be good. Oh, Twitch blocked you for spam too. Sorry about that. Here, I'll wait for you to call me real quick, Sam. It's weird that you're getting ambient occlusion where none should exist. Well, yeah, that's basically what I'm trying to figure out. Why this is wrong, so that's basically the problems. I'm also going to turn off too real quickly. I've got some directional lighting right now, but we don't need that added because it kind of obscures everything else. So let's go ahead and remove that. I can just get rid of that real quick. So we'll do that. Reload, shaders. Okay, cool. So that gets rid of the directional lighting. So basically now all the sides are even. We can just see that ambient occlusion. Okay, let's see. Hey, what's up, Sam? Can you hear me all right? Because I cannot hear you right now. Let's see. Real quickly, I'm going to go ahead and turn off the music so that I can actually hear you. Go ahead and close that down real quickly. Okay, are you there?
Yeah.
Okay, now I can hear you. Yeah, I just had to turn up the volume a little bit. Cool.
So can you turn on the Discord streaming?
Yes, I'll click on the stream real quick. Here, I'll pull it up here too so everyone else can see. Let's go. I really suck at Discord. I don't think I see a stream going on right now.
No, I meant your stream because right now I am on Linux and I don't have compiled the Ember Sky.
Gotcha. Okay, here. Let's see if I can share my screen on two different things at once. Okay.
I will navigate you. So basically, if you take one side of the block and just visualize the vertices in your mind, and basically what you do, you extrude from the center of the block to the direction of the side.
So like up here?
Yeah. This is for the left top vertex. This is the corner block.
Mm-hmm.
And if you extrude down, this is the next block, and right of the top one.
And right of the top, so right here?
Yeah, here. And this is for the side which you are looking at right now. I mean, this is like I don't know, left or right. And this is the top left vertex. This is the blocks for the top left vertex. For each of the vertex on this side, like extrude the corner, bottom of the corner, and the right side of the corner in the direction of the vertex.
So bottom of the corner and the right side of the corner in the direction of the vertex?
Yeah, if you delete these three blocks.
Okay.
And look at the wrong light one.
Well, here, let me do this real quick too, just that. Okay, so based on this block, yeah.
So, select one side.
Okay, this corner right here.
No, you cannot select the corner. You need to select side.
Okay, this face right here.
Okay. Now select the top and bottom. Right bottom vertex.
Okay, so right bottom. So this vertex right here.
Yeah.
Okay.
What do you think is the right three blocks that you need to pick?
So based on what you were telling me, I basically need to go out in the direction. So it would be like right here.
No. This block is right. This is right.
Okay, yeah, that's what I was doing. I was trying to get to here. So this block.
Okay.
These three?
Yes.
Okay.
You are right. It's like this. Yeah. It's in the direction of the center of the block to the point of to the vertex. This is right. This is the corner block. The corner blocks in your algorithm is correct.
Okay.
Only thing it's not correct is the X and Z blocks.
So these two.
Yeah.
So.
It always needs to be in the direction of the side.
Okay. So let me ask you this then. So basically we can get this block, and then can I get these two blocks just by taking a vector from this corner to the center of this block and then taking the Y and the Z directions?
I don't know if you can make it just with the subtraction. I needed to do cross product of the like next vertex of the current one. And cross product it with the side direction to get the right position.
Okay, so you had to do a cross product. So basically you did like a vector from here to the center of this block itself, right?
No.
Okay.
I took this vertex, took the next one in the vertices of the block, made direction of it like like if you look at the right bottom vertex.
Mm-hmm. Yep, this one right here.
Yeah, and so basically I did direction from this vertex to the left vertex.
From this one to the left, so this one right here?
Yeah.
Okay.
Direction, and cross producted, I made cross product with the direction of the side. So the vector will point upwards. And
okay.
The cross product of these two, it's the block down here.
Right here?
Is the no.
Oh, right here.
Yeah. And this is the product of the cross product.
Mm-hmm.
Basically, then you can take this block and make the top one from this one. I will just check the code.
Mm-hmm. I think we might be able to simplify this a little bit more. Here, let me just double check real quick, and then I'll see with you. So let me just make sure I have this right real quick. So if we were looking at this corner, I could place block here and here, and those are the correct 3 blocks, right?
Yeah.
Okay. And then if I was looking at this corner, which is on this face. Oh, wait, no, I already see a problem with my technique. And then this one and this one.
Yeah.
Well, yeah, I already see a problem with my technique. Never mind. Okay, so you're saying basically we can do a cross product. So we would take the vector pointing up and down here, or the vector pointing like from the...
It doesn't matter which vertex, next vertex you choose. It can be the vertex before or after. It will just have inverted positions.
Okay, so we just use one of the surrounding vertices, so either this one or this one. Okay, and then we cross it with the opposite?
No, you cross producted with the direction of the side. So basically,
like that.
Each side has like direction to the world, like this.
Oh, so you're saying like pointed this way?
Yeah.
Okay. So like the normal on this face.
Yeah. So basically the normal of the box.
Okay, so if we crossed this with the normal on this face, wouldn't that's going to point down? If we cross this, here, I'm going to draw this out real quick because I think that's going to be a little bit easier for me. Yeah, let me just switch real quickly. Hopefully the stream is still going for everybody else too. I'm not quite sure if I can stream on 2 different things at the same time, but yeah. Let me actually switch that over on the actual stream too for you guys real quickly. So let's go over here. And then I'll switch for you too, Sam. So then I'll go there. Okay, so.
I see blue screen.
You might have to click off the old stream and then click onto the next one.
Oh, yeah.
Okay, there you go. So basically what we have is like a cube, right?
Yes.
Okay, and so if we're looking at this vertex, you're saying I would take the vector going down, right? This vector? Or I could take, here, I'll do a, whoops.
So, you need to take the vector to right or up right now. So,
here.
Vertex, like this, take the current vertex and subtract it with the previous or the next one.
Sorry, give me 1 second. My tablet is completely screwing up. I think it's just because of Windows. Been having problems lately. Okay, let's see if I can do that. Do that. Okay, so you're saying I can take like one of these points, right?
Yes.
Okay, so that would give me a vector that looks like that, right?
Yeah.
Okay, and then you're saying then I take the normal of this, right, which is pointing out, right? So that, and then I cross these?
Yeah.
And if I cross these, that's going to point down, right?
I think so.
Yeah, like if you do the...
I don't know
or
which vertex I am using right now because I have pretty like messed up.
Yeah, I'm pretty sure this will give us a vector down. So if that gives us a vector down, though, what do you do after this?
I add the direction to this position.
Okay, so that would give us Like right here, right?
Yes.
Okay.
And now you add the position, the direction of the face.
Oh, so the direction of the face. So then you would go out this way?
Yes.
Okay, okay. I see what you're saying now. So then if we were like looking at this vertex, we would use this vector.
Yeah.
And this vector, which would go down. And then if we add that, then we're going to get... And we have what? The
corner block.
Yep. And then what we can do is we can use this vector and this vector to go... Or I guess in this case it would be this vector and this vector. So we would go out that way one. And then I guess this vector and go up. Okay, and that works for all cases. Let me just double check real quick so I can make sure I'll do one more corner just to make sure I really understand this.
I think I'm using the opposite the vertex before, because like when I do this calculation, I think I have the X or a Z block, not the corner block. I calculate the corner block like I just add the direction that you calculated, and I get like one of the X or Z. I don't know right now. I will check it.
Like one of these two?
Oh yeah, I know what I'm doing right now. So for I think it's the X block. I just subtract the current vertex with the next one, and that will give me one of the X or Z blocks. And then take this block and cross product it with this face direction.
Okay, so then you basically take the X. So if we took the X value and then we did it with the normal again like that, then that would give us a vector pointing up, which would give us the correct direction. Okay. Yeah. Okay, so cross products and stuff. Thank you for the help. Let's see if I can actually implement this. I'll go ahead and try it out. And
yeah. If you are stuck, you can look at my code. Like it's not that hard. I just like subtract the current vertex with the next one, and this gives me like the current block, the X or Z block, and then from this I just cross product it with the face direction, and this will give me the next one, and the corner block is just simply adding the direction that you calculated.
Okay, yeah, I think it'll probably be simpler in the code once I get that up and running. Thank you again for the help. Yeah.
Okay, no problem.
All right, so I'll disconnect real quick and then just continue on stream. Thanks though, Sam. Okay, let's see. I didn't close out stream. Cool. So that was very helpful. Thank you again to Sam. He is too low for you guys to hear. Oh, crap. I'm sorry, guys. So that was basically just nothing that you could hear that whole time. Oh. Next time, so I got to be prepared next time I'm going to have a call so you guys can actually hear what's going on. Could you at least see what I was doing on the stream and everything, though, so you kind of have an idea of what I'm going to be doing, which is basically taking some cross products and stuff to get the correct vectors to get the correct blocks. Hopefully that much was clear at least. Oh, you just turned it way up and then you heard. Okay, so that works too. Cool. So basically, let's go ahead and try and implement that then inside of Chunk. So I've kind of got this thing, which is actually completely wrong now. So let's go ahead and we will say where I'm doing the calculations for this stuff. Okay, yeah, so this is where I'm getting like the directions that I need. So we can just fix that. But I was deafening. Okay, yep. I will try and fix that next time. So basically what I'm doing here is this is the center of the current block. And what I need to do is I need to get like the next vertex. Let's see. Okay, I'm trying to figure out, because I know I get all the vertices for the different sides of this specific face. I just have to see where exactly I'm doing that, which I think is somewhere in here. Okay, so this is looping through the different faces of the block. Okay. And then trying to see where I actually get the vertices for this specific face, because it should be in here somewhere. Okay, I guess it's these. These are the vertices for the specific faces. Okay. So basically, I just need to take like whichever one I'm on currently, which is IV. Okay, so this is my current one, and then if I just add, I should get the next one clockwise direction, I believe. So what we can do is we can say, for now, I'll have to change this. Current vertex position equals that. GLM vec3 clockwise vertex pose equals that v plus 1 mod 4, which should be good. This should be size 4. Okay, yep. So these are all of size 4. Cool. Yep, all IVEC4s. So that should work. Okay, so then I can cross these. So I can just say GLM cross current subtract. Oh yeah, you're right. Thank you. I need to subtract that and then cross it with the normal direction. Okay, that's right. So we need to say, so we'll just say this is like the direction, I guess, for now, and then we'll change that clockwise. Vertex minus current vertex pose. Okay, so we'll do that, and then we can cross that with the normal direction, which is, I should have it somewhere in here. Cube face. Okay, so the cube face gives me which face this is, which I think I can get the normal. Do I have the normal in here somewhere? I might not. Let's see. Get normal. Nope, I do not. Okay, or maybe just normal. Okay, nope, that's not good either. Let's go back to here. Not there. Okay, we'll go back. One more. There we go. Okay, let's go back to here. We'll create a function real quick to get a normal from the face. Since apparently I don't have that. So we'll just say static glm vec3 get normal from face cube face switch face. Whoops, that's wrong. Switch face case cube face back. I think that's the negative X direction. Let's actually, I think I have this in the shader code, which is really bad, but I do. And we can just steal this. Let's go ahead. We'll grab all that. Paste it here. Okay, so let's see. What's cube face 0? Cube face. Okay, back is 4. So that must be left. Okay, this is left. Then we'll say return glm vec3. Okay, this one is probably right. Okay, that's right. And then we'll just say return. This one, and we don't need those breaks, is down. Or I guess bottom. Okay, yep, that's good. We'll say return. That. This one is going to be up. Or I guess top. Return that. Oh, I need a vec3 there. That would be helpful. Okay, and then here, this is going to be back. Yep, that's right. Okay, and then we'll say return that, and then front, and just double check. That's 5. Cool, we're good. Okay, cool. So we do that, and then here we'll return glogger assert false bad face. Cool. So we'll do all that. We should be good. Now we can get normal from face. So let's do that. Okay, so right here we'll just say glm vec3 face normal equals get normal from face. And then I need to give it which face we're on, which is whatever this is, cube face I. So we will do that. Okay, and I may very well be duplicating code here. So let's say to do, make sure you're not duplicating code here. Okay, so we got all that. We have the face normal now. We can go ahead and say direction, and then we can say cross equals direction, or I guess glm cross direction with face normal. Okay, cool. So that gets us the direction we need to go down or up, I guess. Okay, and then we need to add the face normal to that. So basically then what we need to do is we need to say like this is the center of the block, which I guess is just current vertex pose. So I'm going to do current vertex pose plus, or actually I guess we could just say next, I guess AO block center, or I guess we could just say AO corner block equals the current vertex's position plus the cross, and I'm going to do times 0.5 so that we don't go too far, and then plus the face normal times 0.5. Okay, so that should get us the corner block, and then to get the side block, and Sam, you had the subtraction in vertex. Oh yeah, I could probably like move that up there. I'm just like writing everything out just so I can make sure it's all correct right now, and then I can go ahead and fix stuff up afterwards. Let me just make sure that this, what is this doing? Oh, I guess this is kind of irrelevant. I could have put everything in here, honestly, but yeah, it's fine. So we can basically just, let's remove this for now. Go back here, and then we will just say, get rid of all of this for now. Okay, and then we'll get the blocks from these. Okay. So then the side block, we would do the negative of the direction, right? We would say AO corner block minus direction times 0.5, I believe. And then we would say the other side block equals, or wait, you were saying I had to do some cross product stuff. You don't need to subtract anything now. Inverted. You have the subtraction inverted. Oh, do I have the subtraction wrong here? Oh, yeah, you're right. That should be that. Okay, so we've got that. And then the side block. Yeah, I'm pretty sure this is right. So then we would do minus the direction. And now I have everything I need. Yes, I believe so. No, I need one more. Because here, let me go back to the drawing screen real quickly so we can all see this. So basically, I have this stuff. Oh, crap. And I didn't even realize I was drawing over here where you guys couldn't see. Sorry about that. Let's move all of this to the right so that you can see. Okay, so what I've done is I've gotten this vertex, right? That's the AO corner block. Okay, then if I subtract the direction, which is this thing, then I get this block, right? And then I can subtract the cross product results. Yeah, I can subtract the cross product result from this corner block, and that will get me to go up, and that should get me the block up here, I believe. Like, I'm pretty sure that's right. I guess we'll kind of see, and we'll see if that works. And then if it doesn't, we can take a look at your code, Sam, and see what I'm doing wrong. Other side block, because you already have everything. No need to subtract anything. Well, I need like the vertices. They can't be on the corner. Otherwise, I won't get the correct vertex with my with this code. Like it needs to be somewhere inside the bounds of the actual block. Otherwise, it's not right. I might be able to use some of the stuff I have up here. Maybe I am doing this a little bit wrong. But for now, I think I need to do like this minus... what's it called? The cross. Yeah. There we go. And then I can just use that. And that. SE Woods, does cross product only work for 90-degree angles? No, it works for any angle. And so the quick way you can do cross products, my physics teacher taught me this, and I never understood it. Here, let's actually go up to Big Meat real quickly so that you guys can see this. The way you can calculate a cross product really easily is if you do like an axis formation with your fingers, right? So if you see, I've got like the x-axis, y-axis, and z-axis, or I guess you could say that's the z-axis. And you basically orient your fingers in the direction of the axis. So if we were looking at this formation right here, I would use my left hand there. Some people call this like the right hand rule and everything. So I would use my left hand here. And I guess in your guys' way, it would look like this. No, it would look like this. I think that's right for you guys. Basically, you just orient your hand in the direction of the vertices. I think it's this way. Yeah, so you would orient your fingers in the direction. And then to figure out what happens when you cross those two vectors, you would curl your fingers. And so basically, if I was crossing these two vectors, these two, then it's going to give me a vector that points down, since my fingers are curling towards the down direction. My physics teacher tried to teach me this in like high school, and I never understood what was going on. But that's basically what happens. So, yeah. Oh, I see. What do you know the hand thing? Okay, yeah. I just thought it was so cool. And remember that the hand you use depends on the handedness of your coordinates. Does it? Or as long as you orient your fingers in the correct direction? I don't know. I think you're right, because I think that's why they call it the right hand rule, because you have to use the appropriate hand. But yeah. Lol Guy 91, is it possible to do that debug performance heat map thingy on Linux? It should be if you compile. And you're on the correct branch and everything, and you change the code like I did there. It should be able to do all that stuff. There's nothing special about it. It's just like all in my code that's local right now, which is why you wouldn't be able to do it right now. But you had forgotten. Okay, well, now you've been reminded, which is good. Let's see if this actually works too. Hey, nice job, Sam. Compiling on different operating systems is always scary. Joe Mega, cross product doesn't care about handedness, but when you have it in a coordinate system, you care about it. Okay, gotcha. Okay, so now this looks kind of off. This looks right. Okay, so that's better. Okay, this is definitely wrong. Wait, no, is it? So I've got this block here. Yeah, so we've definitely got problems. Let's switch our views, I guess. I don't know, to see what's happening here. What happens if I place a block here? That does not change. Ignore the background. I'm going to fix that in a minute, too. That does not do anything. Okay, what about if I did here? Okay, then that adds one here. Yeah, so something's definitely wrong. I think what's probably wrong is I'm not actually taking... It's only correct in certain directions, it seems. Yeah, I think you're right. I think I might not have my vertices in clockwise direction, which is probably why that's wrong. So V0, 1, 2, 3 may not actually be clockwise. Where do I set these? So if we go to verts. Oh, yeah. So this is definitely probably the problem. Okay, so vertex 0 is XYZ. Vertex 1, let's go to the drawing screen real quick so I can actually see what's happening here. So let's go ahead. draw a simple square with my mouse because Windows doesn't like me. Okay, so if we go here, so if this is the vertex that we're looking at, that's 0. Then 1 is vertex 0 plus right. So this is 1. 2. Oh, wait, this isn't even the right thing. I'm looking at the wrong thing here. Wait a second. Okay, let's see. Let's go back to the code real quick so you guys can see what I'm looking at. Okay, so this is not the right thing because we're taking in front and up too, which I don't think. I think this is getting all the vertices. This is saying Vert Indices. Let's look at Vert Indices. Okay, so this is what I should be looking at. So this gets 0, 4, 7, 3. I think I have a diagram somewhere. Let's go ahead and see if we have that diagram still somewhere. Oh, and I'm zoomed in for some reason. Not here. Somewhere way up here. Because this was a long time ago. Okay, here we go. Yep. Sweet, so we do. Okay, so 0, 1, 2, 3, 4, 5, 6, 7. So that's what the vertices look like. So then if we were looking at the left face, which is this one, it says 0, 4, 7, 3. So that's 0, 4, 7, 3. Okay, wait, I do think these are clockwise. The right face is 2, 6, 5, 1. So that would be 2, 6, 5, 1. That seems clockwise. Clockwise. From the direction of the faces. Clockwise. Yeah, okay, I think these are in clockwise order. Okay. Let's take a look at that again then and see what's going on, because I think that's fine. Let's do some debug drawing, maybe? No, that's not going to work. I was going to say we could draw like the cubes around it, but of whichever block I'm looking at, but I'm not sure how well that would work. Okay. Let's take, yeah, let's, like you were saying, Joe Mega, I think it's only working in one direction. So if I do it this way, that's still wrong. What about this way? That's still wrong too. What about this way? That's still wrong. I think it's closer though, because that's like slightly brighter, darker. You know what else it could be too? I changed, so basically each different state has its own weight. Yeah, let's change this to 2. This to 8. It's basically how much each state is weighted at. Let's reload. Okay. Yeah, so that changed things pretty drastically. So that might have been a problem too. Okay, I think this is correct. Close? No, I don't think that's correct. Huh. Yeah. Let's look at the states real quick and see if we're at least getting the right states and stuff. Let's go down here. We will uncomment that and comment that stuff out. Okay, let's see if we're at least getting the right states. So this is all wrong. What about that? That's wrong. What about that? That's wrong. Okay. Yeah, these are all wrong because these should have the same state. Like that one's could be different, but these two should have the same state at least. Now they have the same state, but I don't think that's right either. So what's going on here? Because the last subtraction operations are gone. Okay, that's what I figured it was probably the problem. So what am I doing wrong with these two? The vertex subtraction and cross is the only thing I need. Oh, are you saying I add direction? So this is current vertex pose minus clockwise vertex pose. Yeah, I'm still not... Like, I feel like this should work. Your direction and cross variables are the right blocks. Direction and cross. But this is just giving me an offset, right? Current vertex pose minus clockwise pose. So this is just an offset. So I still have to add this to something, right? Yeah, just add side directions to them. So are you saying I should basically, okay, so this current vertex pose plus cross plus face normal. Are you saying I should just do this plus that? Nope. Okay. So this definitely gets me the corner block. And then the cross, and these are just offsets. Like these aren't getting me any sort of, because we still need to add the current vertex position somewhere into there, because this isn't going to give me, like this is just a normal almost, right? Current pose plus cross plus side dir. Current pose plus cross plus, oh, I still have to add the cross in there. So you're saying I have to do like that? And how's it going, Hujas? I think I said your name right. I remember we went over this one time. If I said it wrong, I'm sorry. Let's see. Cross. And then current pose plus direction plus side dir. Okay. So we've got current pose plus cross plus direction. Current pose plus cross plus... See, but I don't see how this would work, because if we go back to drawing, and you like to say, as long as I'm recognized that I am meant, it's fine. Okay, that's good. Is it Jujas? Jujas? I think, maybe? I might still be saying that completely wrong, and if I am, I'm sorry. Because if we scroll all the way back down, I've sent you example code to Discord. Okay, let's check that out real quick. Let's open up Discord, guys. And I'll switch back to main. Okay, so we've got... Let me just copy this into the main code as a comment. Okay. So you got vertex offset down, which in my case is, so you're doing that minus that. So that's my direction, I think. Is it, or is this a vertex offset right is cross, side direction, vertex offset down? Yeah, so I think your vertex offset down is the same thing as my direction. Okay, yeah. So that's direction. That's cross. I guess I probably shouldn't have done that. So this is direction. This is cross. And so if we do vertex offset down, that should be direction. Okay, and then side dir. What is side dir? That's the face normal. Okay, so side dir is face normal. Okay, and then that would be vertex offset right, which is the cross. And then just pose plus direction. I don't think these are getting the blocks that we were talking about then. Wait a second. Let me just... So pose plus direction, which is that, plus face normal. Okay, so that's, yep. That gets us the corner block. Pose plus cross plus face normal. Wait, no, this gets us the corner block, I think. Okay, it got really quiet too. I think the music stopped playing. It did stop playing. Let's go ahead and grab another one. There we go. 3 hours of relaxing Nintendo music. That sounds good. Okay. Corner is the XZ. Pose plus direction. which direction is, I completely forgot now. Direction is this one. Okay. Why do I have corner as cross plus face normal then? Do you just combine those all into direction? The ATIVATA account in your DMs is my old Discord account, by the way. Okay, cool. Ativata. I think that's how you say that. I might be wrong though. I think corner block is this plus this plus this. I'm pretty sure that's right, because if we look at the drawing real quick, yeah, let's go back up to here. Okay, so this is direction. This is face normal. So then if we do corner plus the cross, that gets us down here. Corner plus cross gets us down here, and then we do the face normal. And if we look at the code again, corner plus cross plus face normal. Yeah, I think that's what that is. So that would be this one, I think, is the corner block. And then direction is just that. So that would be pose plus direction. Oh, pose is not the vertex pose. Okay, so that's where I'm going wrong. It's the XYZ position in block. Okay. So like, is that like the center of the block? How's it going, Lime Dye? Good to see you. Okay, so vertex offset. Okay, so this is this plus the pose, I'm guessing, is the actual vertex position. Okay, so that makes sense. So vertex offset minus... Okay, yeah. So pose plus that equals that. I guess we'll call this block pose, because that just helps me out a little bit more. So block pose plus direction plus face normal, and direction is... Okay, so let's go back to the drawing screen real quick. I just have to map this all out in my mind. Okay, so block pose, which would be the center, plus direction, which is this guy, so going that way, plus the face normal, which would be that way. Okay, so that's like going... If we were looking at this one, that would like go here, and that would get this corner block right here. Okay, okay, I see now, yeah. And then block pose plus cross plus face normal. So block pose plus cross. So this plus the cross would get us down, plus the normal would get us... Okay, I see what's happening here now. That makes sense. And then plus direction, which is that one. Okay, so I think this is what's flawed. It's... Okay, yeah, so when I was... Okay, I think my whole mental model was flawed. I think that's the only problem we have here. This makes sense. The music got quiet again. That's weird. Yeah, it's still playing. It must just be quiet music. Okay. Okay, so yeah, I think what is happening here is my whole mental model was flawed. Let's go back to the screen. Basically, if... Okay. If we're looking at this corner right here, I think what we're getting is we're getting these three blocks. Or at least that's what's happening in my drawing and stuff. I think that's where I was going wrong. I'm just going to go ahead and implement what you've got here and see what I get when I do this. So we say current vertex position is this. Clockwise vertex position is this. So then we get the direction, we get the cross. Okay, then we get the corner. which is actually plus the direction. Let's actually use our block position too. So that way we don't have to do the 0.5s and everything too. So we can just say, where is our block position? I think it's just XYZ. Nope, it's not. It's XYZ plus 0.5. So we'll just say vec3 block pose equals that. Okay. So then if we do this plus the direction, I think that should get us the first one. I'm just going to do what you have here, Sam, and we'll see what happens. Okay, so let's just do this. So that would be block pose plus direction plus face normal. I guess it doesn't really matter which ones I use here, so we'll just say plus that plus that. And then this one would be block pose plus cross plus face normal. And then block pose plus direction. Okay, let's see what happens. And then if this works, I'm just going to have to study this a little bit more on my off time when I'm not on stream and like trying to think of a million other things at the same time too. Okay, so if we do this. Okay, then we go and we go ahead. Okay, that's wrong. Yeah, looks like this is rotated wrong. And we're getting all sorts of weird stuff. Whoa, this is crazy. Okay, so let's see real quick. This says it's a green state. Which state should this be? Actually, let's see if it changes real quick. Yeah, so, well, actually, that's still a green state, but those ones are changing. So something's definitely not right. Lime dye, vector algebra. Yeah, vector algebra is fun. Okay. I definitely don't think it's still green. I don't know. I think this might be close. Let's see what happens if we just add the actual colors back real quickly. Sam, maybe some of the subtractions will be inverted in your code. I don't know how you have the faces oriented. Yeah, that's true. It could be slightly different. Let's do this real quickly. And we'll see what we get. Reload shaders. Okay, yeah. So this is... I think it's close. It's just... yeah, because it's getting the same thing there again. Getting the same thing there again. Okay, I think it's just rotated. Yeah, okay, so we've just got it rotated. So I must have it inverted or something. Did I do this right? Maybe I did this wrong. XYZ. This might be the wrong position. Let's go. I think the easiest way for me to do this is just go to that slash that. Okay, let's go here. And let me see how I was doing it before, because that's going to be the simplest way for me to figure this out. Okay, let's go to that. Oh, I'm on the wrong branch. That's not going to be helpful. Let's go to here. Okay, and then if we scroll down, there we go. Cool. So yeah, I'm using x plus 0.5, y plus 0.5, z plus 0.5. So that's definitely the block center. So this should be fine, assuming this does that, which I'm pretty sure it does, but that's good. Try to invert the subtraction in the direction. Oh, so maybe I did have this right the first time and I just flipped it because we were operating on different axes or something. At least it looks like it's getting the correct things though. It's just all inverted and stuff, so. Yeah, I think That was right. It's just they're all rotated weird. It's weird. Okay, so I'm definitely getting the right blocks here, I think is the thing. Somehow, yeah, somehow I'm getting the right blocks because this is all working. But yeah. That rotated by 180 degrees. Oh, and that makes sense because I just inverted that, yeah. Switch the corner with the X. Oh, you're right, because I didn't even... Okay. Yeah. So, I said it doesn't matter which one of these is which, but it does matter because I'm using them here. And then passing them through here. So... Let's see. So this corner block should be this one. This should be according to yours. Okay, so you say X is direction plus face normal, which would be this one. Okay, I think that might fix it. I might have to swap those two. Those might be wrong. I see what's blowing cats and dogs over here, so having internet issues. Oof. It was like blowing really strong wind out here too the other night for me. Last night, I think. Okay, so I think that's fine. I think I just need to swap those last two. Let's do that. Swap it with that. I didn't even think of this, but this is actually very important for these to be right because otherwise it throws everything off. Corner block should not have added face direction. Did I mess that part up? Did I mess up the corner block by adding face direction? Corner block is block pose plus direction. Yeah, I think that's the same as what you got here. And then plus direction plus face normal plus cross plus face normal. Yeah, that's the same things I got there. Wrong positions to get block internal. Oh, am I sending? Oh, okay. I see what you're saying. That should be here. Yeah, I was all over the place here, wasn't I? Okay, and that should be here. Let's see if that fixes things. XZ should be the corner. Yeah, that makes sense. For those of you who have never coded on stream, I was talking to Sam about this the other day, and it's actually a lot harder than you would think to think about all this stuff and your code and everything and make sure it's all working right too. Okay, I think I just have to swap those last two, and I think we should be good. So if we just do that there, and that there, which is also why, I don't know how many of you guys watch Randy, but I'm pretty sure that's why he stopped streaming, because it's really hard to be productive and like actually work when you're streaming and stuff. So yeah. Okay, so it looks like we still have some problems though. It's still rotated. Like they're all just off by one somehow. Does this game have flowing water? It does not yet. That's something I'll be adding eventually, but not right now, unfortunately. Maybe now the subtraction? Yeah, let's try the subtraction again. See if that's inverted. I think that's just going to invert it again 180 degrees though, so we'll see what happens though. Or if I've added the 0.5 wrong. No, I checked the 0.5. The 0.5 is definitely correct, so it's got to be something else. Let's see. Okay, yeah, so that inverted it 180 degrees, like, I think Lime Dye, you were saying that. Oh, Randy used to stream with the chat closed for a while. Huh, did not know that. So that inverts it. We don't want that, though. Is it because of the way I'm doing this? Let's subtract one. No, I can't subtract one because that'll do stupid problems. Let's add 3. Or add 4. Yeah, add 3. Which would be like subtracting 1 because we're there. We got modulus. So I don't know, though, because I think that's right. I think the directions and everything are right. Wait, did that do it? Look at that. Okay. Finally, but it's not right because these are all still broken. At least it's working for this case. What happens if I do that? Okay, that's still working, right? Oh, wait, no. This was working wrong then because... No, yeah, that looks right, I think. This does not look right, though. Or at least it looks different. The cross, I've swapped components. That might be important. Okay, and then that looks like that. We're getting some weird stuff up here, too. What happens if I do that? Okay, so this is definitely wrong. Isn't the edge too dark? Yeah, that's what I'm thinking. Like oh yeah, you're right. This edge is too dark. That's what's happening there. Yep, that edge is too dark. You're right. Huh. So this one's rotated wrong. Maybe you're right, Sam. Maybe I think if you do cross things differently, that does have an effect. So you did cross side direction with vertex offset down, which is face normal. Okay, yeah. Let's see what happens if we do this. Maybe that was it. Whoops. Okay. Load that. Okay, and then I'll switch back to what we were doing before, which was taking the +1 and see what happens there. Because I think going +3 would be counterclockwise, which is not what we want. Okay. That looks right, but now we're getting darkness up there, which it's very close. It's just not there. That looks right at least, or at least a little bit better. This one is wrong though. Yeah, and that's wrong too. Yeah, and it's definitely wrong over here. It's only on one side, the face. Yeah, something weird is going on here. We are very close, guys. I might have to just finish this off stream just because it'll be a little bit easier, and I might just redo it completely. I know what I need to do. I think we've kind of covered that with Sam's help on the call and the drawing and everything. I know what should be happening. I just need to actually add it so that it does it correctly and stuff. And hopefully you guys will see some pictures or screenshots in the Discord in a minute, which shows it all working. So yeah. But I appreciate you guys all coming out and watching today. It was good to see everybody. And hopefully I'll see you guys next week too at around 8 a.m. CST. Possibly a little bit later for next week's stream. But yeah, good to see everyone. And thank you all for the help. So I'll see you guys next week.